Understanding conduit support requirements is crucial for safe and compliant electrical installations. Without access to specific codes or online resources, we must rely on general principles and best practices. The National Electrical Code, or NEC, provides detailed guidelines for conduit support, but let's discuss some fundamental considerations. The purpose of conduit support is to prevent sagging, maintain alignment, and protect the conductors within the conduit from stress and damage. Proper support ensures the longevity and reliability of the electrical system. Conduit support spacing is determined by several factors, including the type and size of the conduit, the type of support used, and the environmental conditions. Different types of conduit, such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and PVC conduit, have different support requirements due to their varying strengths and weights. Generally, heavier and larger conduits require closer support spacing. The NEC specifies maximum support intervals for each type and size of conduit. These intervals are designed to provide adequate support under normal operating conditions. For example, EMT typically requires supports at intervals not exceeding 10 feet, while RMC may allow for longer spans. However, these are just guidelines, and actual support spacing may need to be adjusted based on specific circumstances. The type of support used also affects the required spacing. Conduit straps, clamps, and hangers must be appropriately sized and rated for the conduit they are supporting. The support should be securely fastened to the building structure to prevent movement or displacement. In areas subject to vibration or seismic activity, additional support may be necessary to maintain the integrity of the conduit system. Environmental conditions, such as temperature and humidity, can also influence conduit support requirements. Extreme temperatures can cause expansion and contraction of the conduit, which can put stress on the supports. In corrosive environments, it is important to use corrosion-resistant supports and hardware to prevent premature failure. When installing conduit, it is essential to pay close attention to the manufacturer's instructions and local electrical codes. The NEC provides minimum requirements, but local codes may be more stringent. It is always best to err on the side of caution and provide adequate support to ensure the safety and reliability of the electrical system. In situations where the conduit run is particularly long or complex, it may be necessary to consult with a qualified electrical engineer or contractor. They can assess the specific conditions and recommend appropriate support solutions. Furthermore, when dealing with conduit bends, the NEC typically requires supports within a certain distance of the bend. This helps to prevent stress on the conduit and maintain its structural integrity. The distance from the bend to the nearest support depends on the type and size of the conduit, as well as the angle of the bend. For example, for IMT, supports are often required within 3 feet of each bend. The specific requirements can be found in the NEC. When using couplings to join sections of conduit, it is important to ensure that the couplings are properly tightened and secured. Loose couplings can cause the conduit to sag or separate, which can damage the conductors within. It is also important to provide adequate support near couplings to prevent stress in the joint. While it is difficult to give specific support spacing recommendations without knowing the type and size of conduit you are working with, it is generally good practice to provide supports at regular intervals and near bends and couplings. This will help to ensure that the conduit system is properly supported and protected. In summary, without internet access to specific code references, understanding the general principles of conduit support is essential. Consider the type and size of conduit, the type of support used, and the environmental conditions. Provide supports at regular intervals, near bends and couplings, and in accordance with manufacturer's instructions and local electrical codes. When in doubt, consult with a qualified electrical professional. The NEC provides guidelines for conduit support spacing, addressing the maximum intervals for different conduit types and sizes. These intervals prevent sagging, maintain alignment, and protect conductors. However, actual spacing adjustments may be necessary depending on specific circumstances. Common conduit types include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and PVC conduit, each with unique support needs based on weight and strength. The type of support, whether straps, clamps, or hangers, affects spacing and should be correctly sized and rated. Secure fastening to the building structure is vital to prevent displacement. In areas prone to vibration or seismic activity, augmented support ensures system integrity. Temperature and humidity influence conduit behavior, causing expansion and contraction at stress supports. Corrosion-resistant supports are essential in corrosive environments to prevent premature failure. When installing conduit, adherence to manufacturer's instructions and local codes is paramount. The NEC provides minimum requirements, but local codes may impose stricter standards, so erring on the side of caution is prudent. Complex conduit runs may require consultation with electrical engineers or contractors for appropriate support solutions. Conduit bends necessitate supports within a specific distance to prevent stress, contingent on conduit type, size, and bent angle, with EMT often needing supports within 3 feet. Proper tightening and securing of couplings are crucial to prevent sagging or separation. Adequate support near couplings minimizes stress on the joints. While precise spacing recommendations require knowledge of conduit type and size, regular intervals and proximity to bends and couplings are generally advisable. When in doubt, seek guidance from a qualified electrical professional. In absence of internet resources, the following principles apply to conduit support. Firstly, consider conduit type. Rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and PVC conduit each have different strength and weight characteristics which dictate support spacing. Secondly, determine the conduit size. Larger conduits typically require closer support intervals than smaller conduits. Thirdly, evaluate environmental factors. Temperature variations can cause expansion and contraction of the conduit, while corrosive environments necessitate corrosion-resistant supports. Fourthly, identify local codes and regulations. Local electrical codes may have specific requirements for conduit support that differ from the NEC. Fifthly, consult manufacturer's instructions. Conduit and support manufacturers often provide recommendations for proper installation and support spacing. Sixthly, ensure proper fastening. Supports must be securely fastened to the building structure to prevent movement or displacement. Seventhly, consider conduit bends and couplings. Supports should be placed near bends and couplings to prevent stress on these areas. Eighthly, when in doubt, seek expert advice. Consult with a qualified electrical engineer or contractor for guidance on complex or unusual installations. Ninthly, prioritize safety. Adequate conduit support is essential for ensuring the safety and reliability of the electrical system. Tenthly, document your work. Keep a record of the conduit type, size, support spacing, and other relevant information for future reference. Consider a scenario where you are installing a run of 1-inch EMT in a dry, indoor location. The NEC specifies a maximum support spacing of 10 feet for EMT. However, you notice that the conduit is sagging slightly between supports. In this case, you may need to reduce the support spacing to provide additional support and prevent further sagging. Another scenario involves installing conduit in a corrosive environment. In this case, you would need to use corrosion-resistant supports and hardware to prevent premature failure. You should also consider applying a protective coating to the conduit to further protect it from corrosion. Remember, the NEC is a minimum standard, and it is always best to err on the side of caution. By following these guidelines, you can help to ensure that your conduit system is properly supported and protected, even without access to the internet. The support interval should follow NEC guidelines for each conduit type, keeping in mind the conduit size and material. Factors such as environmental conditions, temperature changes, and potential physical stress also impact ideal support spacing. For example, if using 1-inch EMT in a dry location, supports are needed every 10 feet per NEC standards. However, if the environment is subject to vibration, closer spacing is warranted. If using rigid metal conduit, or RMC, which is heavier, Wider spacing is permissible. Consult NEC tables for specifics. Furthermore, consider conduit couplings and bends. Supports are typically needed within 3 feet of any coupling or bend to prevent stress at these vulnerable points. Always use appropriate hardware such as straps, clamps, and hangers suitable for the conduit type and size. Ensure that these supports are firmly attached to the building structure using appropriate fasteners. Conduct a thorough visual inspection after installation to verify that the conduit is securely supported and there is no sagging or induced stress. If you are unsure about any aspect of the installation, consult with a qualified electrician or refer to the applicable electrical codes. Proper conduit support ensures longevity, safety, and compliance of the electrical installation. When assessing the necessity for conduit support within 3 feet of each coupling, several factors must be considered in the absence of direct access to the relevant articles of the National Electrical Code, or NEC. Firstly, the type of conduit plays a critical role. Different materials, such as rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and PVC conduit, exhibit varying degrees of rigidity and therefore require different support strategies. Secondly, the size of the conduit is also a significant factor. Larger diameter conduits, due to their increased weight and potential for sag, generally necessitate more frequent support intervals. Thirdly, the environment in which the conduit is installed can influence support requirements. In locations subject to vibration, extreme temperatures, or corrosive elements, additional support measures may be necessary to ensure the long-term integrity of the installation. Fourthly, local electrical codes and regulations may impose specific requirements that supersede or supplement the NEC guidelines. It is essential to consult these local codes to ensure compliance. Fifthly, industry best practices and manufacturer recommendations should be taken into account. Experienced electricians and conduit manufacturers often provide valuable insights into optimal support strategies for various applications. In general, it is advisable to provide support near couplings to minimize stress on the joint and prevent potential sagging or separation of the conduit sections. While a specific distance of 3 feet may be a common guideline, the actual distance may vary depending on the aforementioned factors. Absent access to the NEC or other authoritative sources, a conservative approach is recommended. If there is any doubt about the adequacy of the support, it is prudent to provide additional support to ensure the safety and reliability of the electrical installation. It is also important to consider the type of coupling being used. Some couplings are designed to provide additional support and rigidity, while others are not. The type of coupling used may influence the need for additional support nearby. Ultimately, the decision of whether or not to provide support within 3 feet of each coupling should be based on a careful assessment of all relevant factors and a commitment to ensuring the safety and integrity of the electrical system. In the absence of definitive guidance, erring on the side of caution is always the best approach. Keep in mind that providing adequate support not only enhances safety, but also extends the lifespan of the conduit system and reduces the likelihood of future maintenance or repairs. The absence of readily available code information underscores the importance of understanding basic electrical principles and applying sound judgment when making installation decisions.